Welcome back. Let's talk about sedimentary structures. So the rocks themselves can tell you about the source rocks, the mode and energy of transportation, the depositional environment, but some of these structures go on to tell you a little bit more information. So again, sedimentary rocks, they tell a good story. So structures in a sedimentary rock are features that form at the time of deposition or sometime shortly thereafter. And that's deposition of the sediment. Remember, sediment needs to be deposited first. Pressure, a little bit of pressure, a little bit of heat, a lot of time will eventually turn it into sedimentary rock. It's the process of lithification. So these features need to occur, at the time or pretty shortly thereafter the sediment was deposited, because after a while, if it eventually turns to sedimentary rock, you can't do what we're about to do in rock. It has to be the sediment itself. And again, these are manifestations of physical and biological processes that occurred in these depositional environments. So the way we can figure out what these structures are, what these structures in these rocks tell us about the past, is we just look at what we see now, because we have sediment now, and when we see these structures in sediment now, we can infer what they're telling us about the environment. So, for example, we might see some now sedimentary rocks that have these little holes. These are raindrops. So we can infer, oh, this area had rain. Good for that. Things like graded bedding. I'll explain more of these here momentarily. Graded bedding is basically where it goes from larger pieces to smaller pieces. Cross bedding and what that tells us. And then we also have things like ripple marks in a couple of different kind of fashions. So all of these things, again, occur after sediment is deposited. You need to deposit the sediment first before, it can rain and create these little drop patterns in there. We need to deposit sediment first before it can get blown around in sand dunes to create this cross bedding, so on and so forth. So bedding, we touched on this a little bit a couple of units back. Ooh, that was fancy. So that's just a zoom in on these layers of sedimentary rock. Sedimentary rock typically, especially, I should say that, but typically sedimentary rock has beds or layers, or strata. That's stratification. If an individual layer is thicker than a centimeter, we call it a bed. Beds can be made up of smaller laminations. And we also talked about the bedding plane, kind of the top and bottom of the bed, that area where it changes from one bed to the next, and what that can tell us. So when we're talking about cross bedding, this happens when layers come to rest instead of flat at some angle upon which they accumulate, such as when sand gets kind of blown up over a sand dune and it gets deposited on this side. It's kind of piling up at a little bit of an angle. Cross bedding can occur via transportation of wind or even water. Again, these beds are kind of inclined or downward dipped in the direction of the prevailing current, whether it's wind or water. And again, they indicate the direction of flow of ancient current, wind current or water current. So imagine you have sand dunes. It's windy. Some sand gets blown up here. It gets blown on the other side. It gets deposited. Okay. And over time, so that helps you indicate the wind or current direction. Some material gets wind blown, or water pushes it up and over, and it'll build up on this side. And the way these layers are, this cross bedding are, it indicates the direction in which the material is moving, because it indicates the direction the wind or water was moving. So here we have some just horizontal flat bedding, but here we have some cross bedding. This one, let me use this one. So this one, these are all these diagonal faces are these faces here. And so this indicates that the wind or water was moving this way, because it was blowing or pushing this sand dune this way. So what can we infer from this environment right here? Maybe something, so this horizontal sand maybe deposited in kind of near the beach area in this flat area, and then maybe the ocean regressed right? So lowered, and the beach kind of got further out, so now we still have all the sand, but it's more of a windy sand dune environment. So we get these cross bedding, and then maybe the ocean then transgressed, came back up, and now maybe we have this beach environment again, so the sand gets deposited horizontally. So again, they tell you a good story. You just got to know how to read it. Graded bedding, as opposed to cross bedding, shows what's called an upward gradual decrease in grain size. As you're looking at a layer of sedimentary rock, the bigger pieces are at the bottom, and as you look further up that bed, the pieces get smaller and smaller and smaller, known as graded bedding. It's common in something called turbidity current deposits, which we'll look at in a little bit later section. As you get these turbidity currents, it's kind of when, let me just explain it real quick. There's a picture on the next slide. So when you get kind of underwater sediment moving downslope, it moves a little bit slower. It's slower to settle. The heavier stuff is going to settle out first. So you get the bigger pieces. So you get this turbidity current of sediment sloping downhill, going downhill in the ocean. Again, gravity's pulling things down, but the water's kind of holding things up. So the heavier stuff kind of falls out right away. So you get this heavier material falling down, and then the lighter or smaller sediment pieces eventually settle on top. So you get this graded bed. You get this graded bed. Big pieces down here, smaller pieces and smaller. So again, that's all that material coming down. Gravity doing its work. The ocean still kind of preventing some of the small pieces from falling down right away. Heavy stuff falls right away. Lighter stuff on top. So that's known as a graded bed. And so again, we can see that in sedimentary rocks. So what does this indicate? It indicates some sort of environment where sediment kind of flowed down slope in maybe the ocean, and this can happen on land too. And you see the bigger pieces settle out first, and then these smaller pieces kind of grade smaller and smaller upwards. We also have structures called ripple marks. These are kind of what they sound like, small ripples in sedimentary rocks. Usually you'll see these on the bedding planes themselves. But it's a series of ripples, ridges and troughs, usually best seen in sandstone. That's where I've seen most of them. They can form from wind or water flow. They can have asymmetry, and they can indicate original flow or direction. So that's current ripple marks. They're asymmetrical. Wind current or water current kind of pushes these things, and they show you the direction of flow. But then you have wave-formed ripple marks. This happens from the to and fro motion of waves near the beach, and especially if it's maybe a small little lake, and you'll get very gentle little waves pushing in and pulling out. These ripple marks tend to be symmetrical in nature. So, typically one direction of water or wind, you'll get these small little tiny ripple marks. If you were to do a cross section of them, it's like small little sand dunes with cross bedding. But you can see they're asymmetrical, meaning this side is much longer, the downside is much shorter. The upside is much longer, the downside is much shorter. From these ripple marks in mud, from current day, can you tell which direction the water was flowing? Is it to the right or to the left? Oh, so is it to the right or to the left? Well, if you said to the left, you would be correct. Because you have a longer side, shorter side. Longer side, shorter side. So those are current ripple marks. They indicate one direction, the direction of flow, and they're asymmetrical. Wave ripple marks, because of the back and forth nature of waves, even tiny little ones, form symmetrical ripples. So they're all evenly spaced, nice little ripples. This is what we see in sand now. This is what ripple marks look like in rocks. This is what ripple marks look like in rocks. So again, this indicates, depending on if these are symmetrical or asymmetrical, we can figure a little bit more out. Based on the picture alone, it might be a little bit hard to tell. They maybe look symmetrical. I don't know. Yeah, I'd have to take a closer look. But those are what ripple marks look like. You can also see some more in the background here. Continuing on, mud cracks. So when clay-rich sediments, very small particles, dry out, they shrink and crack into polygonal patterns, 4, 5, 6-sided patterns, not lines, but these kind of closed patterns bounded by fractures, and we call those mud cracks. So the way a mud crack forms, it needs wetting and drying to occur. And sometimes that can happen on the shores of a lakeshore, a river, or a flood plain, or where mud is exposed at low tide along the seashore. Sometimes even in interim areas of water and drought like the desert. So, material gets wet, clay particles get wet, they expand. When they dry out, they shrink and they form these, again, polygonal patterns, these closed off, sometimes 4-sided, sometimes 1, 2, 3, 4, 5-sided, sometimes many more sided, but you get these cracks. These are called mud cracks. What that looks like in stone is something just like this. So what this area indicates is that this was a muddy area that dried out, similar to what we find maybe in dry areas if it had rained and dried out, along lake shores, along floodplains as the water receded, so on and so forth. Then we get to blanket or sheet geometry. This is kind of what most sedimentary rocks kind of tell us, but there's some additional things in there. So most of the extensive sedimentary rocks in the geologic record form from marine transgressions and regressions, forming these huge plains of sediment and then thus eventually sedimentary rock. And that is known as kind of blanket or sheet geometry sedimentary rocks. They can, be anywhere from a few 10 meters thick to hundreds of meters thick, and again, they cover a very large area. So they're said to have blanket or sheet geometry. The rocks that make up the Grand Canyon and the surrounding Colorado Plateau are a fantastic example of this. So here's the Colorado Plateau. We'll talk about this more in a later unit. But it consists of essentially a bunch of uplifted sedimentary rock layers. The Grand Canyon cuts into all of those, but you can see how extensive and how far-ranging these sedimentary layers are. So that's blanket or sheet geometry. Sometimes in that blanket or sheet geometry, we get additional structures which can further tell us information. So now we're looking at elongate or shoestring geometry. So these are they kind of look like shoestrings. So some sand deposits have kind of this shoestring geometry, especially sand and typically sand or other bigger sized sediment that was deposited in stream channels. So you can almost imagine that this, was a stream. So what we see sometimes in sedimentary rocks is this. So we get this kind of cross section. So a stream was kind of flowing kind of into or out of this. Imagine this is the bottom of that stream in which water was flowing, through here at one point. You can see the sediment that deposited in there. There's also biogenic sedimentary structures, things created from living processes like tracks, burrows, trails, which are all trace fossils. Some examples of that you see here. These are actually little trails that were in the mud that eventually were lithified into the stone. And then we have dinosaur tracks here. Remember, these are all trace fossils. Okay, so all these different structures can be found in sedimentary rocks. For instance, these dino tracks here. Well, where do you make footprints? You only make footprints in the ground usually if it's wet. So this was an area, and then dependent on the rock, that the sediment was wet. Maybe it was on the edge of a lake. Maybe it was on the coast at low tide. Maybe it was on the edge of a stream that these dinosaurs walked through, created these imprints. They were covered with sediment over time, turned to sedimentary rock. Anywho, we'll pause there. When we come back, we'll talk a little bit more about fossils, more so on the smaller side. See you back here in just a second.